Hi. In the previous video, we were discussing commutative functions and we were discussing elasticity of capital and labor with respect to changes in the production level. However, there is another type of elasticity that is extremely important in the context of long-run production. And look, we are going to discuss it in this video. We're going to call it elasticity of substitution, and this concept is telling us about the ease with which we can replace capital and labor with due to changes in the price ratios. So look, how are we going to calculate? We're going to denote it by lowercase sigma, and it's, as always elasticities, it's equal to relative change in capital to labor ratio divided by relative change in the price ratio, right? So we've got percentage change in capital to labor ratio divided by percentage change in the price ratio. Now, we can, of course, express, if we want to calculate this at every possible point, we're going to use differentials. So relative change in capital to labor ratio is differential of capital to labor divided by capital to labor at this given point. And similarly, relative change in price ratio is a differential of price price of labor to price of capital divided by the ratio of price to capital. And look, very similarly to what we did previously, again, we can express this as ratio of two functions. So look, if I'm going to multiply it all out, I'm going to find out that on the top, I'm going to get marginal function. In other words, here we see the change in capital to labor ratio due to change in price of labor to price of capital ratio. So we've got marginal function here. On the bottom, on the other hand, we're going to have a different rate. We're going to have a different ratio because the only thing left is capital to labor ratio and price of labor and price of capital ratio, which is going to give us an average function. Here we've got average function. Okay, so we know now how to calculate this elasticity of substitution. What about its economic interpretation? Let's start with the sign. Well, should we expect the sign to be positive or negative? Well, if the price of labor is increasing, right, it would mean that price ratio is going up, right? And if price of labor, wage, is going up, what should the company do? Well, most likely, company is going to replace more expensive labor with relatively cheaper capital, right? So of course, if this is the case, we are replacing factor of production that became relatively more costly with one that became relatively cheaper. Of course, the sign needs to be positive. However, there is a question about magnitude. And again, I think the best way to look at it is when we see the corner solutions. So, what would happen if elasticity is 0? how much price of labor is going to increase, the ratio remains the same. This means that the two inputs are perfect complements. They need to always be combined at the specific ratio, so increase in price of one of the factors is not going to affect this ratio whatsoever. So in this case, we will have perfect complements. Yeah. Okay, so let's see the other corner. What would happen if this price elasticity would be infinite? That would mean that if price ratio changes by even a very, very, very tiny amount, it's going to completely change capital to labor ratio. Look, this, as we can conclude, if on one corner we've got perfect complements, most likely on the other corner we're going to have perfect substitutes. And this makes perfect sense in this context. Why? Look, if we have a production process where we can substitute two factors of production perfectly, capital for labor, what is going to happen if capital price is higher than price of labor? Well, then we hire only labor. And if price of labor is higher than price of capital, we hire only capital, right? So this is the case where we would say that we've got sigma approaching infinity, and this is the case where we've got perfect substitutes. Okay. However, of course, the most interesting cases are cases in between those two corner solutions. So let's look at one very specific example of the function that we know very well. So given the Cobb-Douglas production function, we've already established that the optimal capital to labor ratio is given by this expression. And again, let's just summarize what we learned. This makes perfect sense because if price of labor is going up, we expect more capital to be higher than capital to labor ratio go up. If price of capital is going up, we would expect more labor to be higher or less capital to be higher, and now the ratio should go down. This part is associated with prices of factors of production. The second part is associated with the factor intensity coefficient. And look, of course, if beta is getting bigger, it means that the production process here is getting more capital intensive. And in more capital intensive production process, of course, we will require higher capital to labor ratio. And the same can be said about alpha, so labor intensity. If we have more labor intensive production process, we of course expect lower capital to labor ratio. Okay, this is what we already established. Now let's figure out what is going to be elasticity of substitution of these two factors of production, of course, at the optimal long run point. Okay, so first, probably we need to calculate marginal function. Or in other words, we need to take this condition and we need to calculate dKL dPL. Okay, and look, in this case, it is ridiculously easy task. Why? You can think about this as being y, this as being coefficient a, and this as being x. So look, it's like we calculate derivative dy dx, right? In our case, it's a. So this derivative is equal to the coefficient a beta over alpha. So now we've got marginal function. What about the average function? In case of average function, what we need to do is to calculate capital, so labor, divided by PL, PK, so price ratio. Okay, and look, we know the expression for capital to labor ratio. This is beta over alpha times PL, PK, divided by PL, PK. Well, we clearly see that those two cancel each other out. As a result, we get beta over alpha. Okay, and this leads us to our very, very last step. As we know, our elasticity of substitution is, of course, measured here as a ratio of marginal function to average function. However, look, in this specific context, we get that marginal function is beta over alpha, while average function is beta over alpha. And as a result, we see that the elasticity of substitution is simply 1. And look, this result is very, very tidy and nice. And this actually explains again the popularity of Cobb-Douglas reduction function in economics in general. However, right away, this creates a question. Well, we see that in the case of Cobb-Douglas reduction function, elasticity of substitution is always 1. We see that regardless of whether alpha plus beta are less than 1, 1, or more than 1, elasticity of substitution is always 1. So, what if we would like to analyze more general framework in which actually we would like to allow the elasticity of substitution to take different values, expressing, of course, different complementary or substitutionary relationship between the two inputs. And as it turns out, it is possible to do. We can actually use a function that has very similar property as Cobb-Douglas production function. However, it is characterized by constant elasticity of substitution. And this is going to be the subject of our next video. Thank you for your attention. Take care.